Good day, ma'am. I'm Rosa from BSE 1. So, Lecture 6 Mirrors and Lenses. So, problem set number 1. Calculating the pressure changes due to temperature changes. Example 2.1. Suppose your bicycle an absolute pressure of 7 times 10 to the raised power of 5 Pascal. A gauge pressure of just under 90.01 B over m squared at a temperature of 18.0 degrees Celsius. What is the pressure after its temperature has risen to 5.0 degrees Celsius on a hot day? So assume there are no appreciable lengths or changes in volume. So given TO temperature 180 degrees Celsius and for TF 35.0 degrees Celsius, and for our absolute pressure, which is 7.00 times 10 to the raised power of 5 PA, which is kaning at bicycle time is fully inflated. And for solution, TO, which equals to 18.0 plus 273K minus 291K TF, which equals to 35.0 plus 270K minus 308.K. And for PF, which equals to PO TF over TO, which equals to 7.00 times 10 to the raised power of 5 PF. Absolute pressure, which is our absolute pressure, and 308K over 291K, which divided by, so ato ano siyang i-divide and maka-gain tang answer or maka-arrive tang answer nga 7.41 times 10 to the raised power of 5 PA. And for problem set number 2, calculating the number of molecules in a cubic meter of gas, example 2.2. How many molecules are in typically some object, such as gas in a tank or water in a gas? So this calculation can give us an idea of how large N typically is. Let's calculate the number of molecules in the air that is typically healthy. Young adult inhales in one breath. With a volume of 500 ml at standard temperature and pressure STP, which is defined as 0 degrees Celsius and atmosphere pressure, our young adult is apparently outside in water. So given T, temperature, which equals to 0 degree, and for C, which equals to 273 K, and for P, which equals to 1.01 times 10 to the raised power of 5 PA, and for ml, which equals to 500, and for the volume, which equals to 5 times 10 to the raised power of negative 4 m squared. So m cubed brother. And then for KO, which equals to 1.3 times 38 times 10 to the raised power of negative 23 J over K. And for solution are solved by solving for N and PV over KOT, or code 1.01 times 10 to the raised power of 5 PA, which is our P or P, so or our Pascal. And for 5 times 10 raised power of negative 4 M3, which is our katong kanina given volume, and over 1.38 times 10 to the raised power of negative 23 JK, which is our cut or KOT. And makagain tang answer, ato na siyang simplifying, so makagain tang answer ng 1.34 times 10 to the raised power of 22 molecules. So continuation for the problem set number 3. So using the lens maker's equation, example 2.3. Find the radius of curvature of a concave lens symmetrically ground from a glass with index of refractive 1.55, so that its focal length and area is 20 cm for a big concave lens. Both surfaces have a the same radius of curvature. So note, so lens maker's equation, by the lens maker's equation, so noon na to ang equation, so 1 over F, which equals to N2 over N1 minus 1, or 1 over R1 minus 1 over R2. And for given, so F, which is our F, is negative 20 centimeter, and for our N2, which equals to 1.55, and for our N1, which equals to 1.00 gives. So solution, R, which equals to negative 2F N2 over N1 minus 1, which equals to negative 2 minus 20 centimeter, negative 20 centimeter, 1.55 over 1.00 minus 1. And ito na siyang by simplifying. So, makagain tang answer nga 22 centimeters. So, that would be all. Thank you.